Okay, hello everyone. Welcome to the first office hour of the second week of the course. As usual, I'll be taking questions in the live chat. If you have any to share there, you can find that chat adjacent to the video. I've just typed hello into the chat box. And I'll also be looking at questions on the discussion board. I did visit the discussion board once over the weekend and answered some of the more urgent questions there. And I'll review some of those just to advertise those answers. And I'll also answer new questions. Also, I recently uploaded the videos for the first 4 lectures for the week. There will be more lectures, more lecture videos coming out this week. But we've got the first 4 here. It looks like there's about an hour and 10 minutes of lecture so far. We'll probably have about 2 more hours of lecture videos coming out this week. So more or less the first third of the videos. And those cover algorithms and analyzing kind of the efficiency and complexity of our solutions in terms of how much resources we dedicate to running our code. So yeah, if you have any questions for me live, okay. Hopefully there were no issues with the office hour. For some reason, it was telling me an error happened during the streaming, but yeah, if you have any questions for me live, or if there are problems with the live stream, make sure to share those in the chat. Otherwise, I'll just start on some of these questions on the message board. As I mentioned, there were a few where I wanted to advertise some answers I shared over the weekend. Okay, I think it's these 3. One was asking if we can share the mini project solutions after the conclusion of the course. We do not share mini project solutions. The reason is rather simple. We run this course several times a year. We know that many of you recommend this course to your friends. And since this course does have a certificate attached to it, we do not allow cheating. And if we shared these solutions, it would be very easy for future students to come along with the solutions in hand and answer all the mini projects on day 1 without having learned anything. So we don't share mini project solutions. Now, obviously, this has the drawback that many of you may leave feeling like you didn't solve that problem as well as you could have, and you would have really appreciated some feedback on how you could have done better. Well, the good news is, first of all, we're always happy to provide feedback. If you have some solution to a problem and you feel like some part of it could have been implemented better, could have exhibited better coding style, ask a question about it on the discussion board, and me and your fellow students will be happy to chime in. Secondly, there are many other sources of example code illustrating good solutions to difficult problems. Not necessarily problems that you've worked on, but you can always try and pose the problems as an exercise to yourself, solve them yourself, and then look at the solutions. In fact, many of the exercises in the lecture notebooks are exactly for this purpose, where we pose some simple problem you can hopefully work on for a few minutes, and then we show you a solution. Another great source is there are huge open source. There's a huge open source data science community around Python, both making packages like scikit-learn and a number of others, as well as making data science projects. You know, you might look around for examples of other people's projects and examples of their code, and have a look at how they write code. So, for example, I have a link in this question to Jake Vanderplas's website, and there's a link to his blog, where, for example, he simulates the children's board game Chutes and Ladders. And I believe, yep, so he has an example of some code for doing that. So there's a lot of people doing data science projects out there. They often share these with the public. And this isn't data science exactly, but you know, it's not so far away from data science. It's a simulation of a complex problem, a mathematical problem. So you should search for these kinds of projects and have a look at their code as well. Especially if you can find people like Jake Vanderplas, who is a contributor to scikit-learn, and an astronomer who you know, writes very excellent code. So looking for people working on data science projects, especially those who have contributed to the open source projects that the data science community uses, like scikit-learn. So there are lots of resources out there for you that accomplish the same objective as sharing mini project solutions without actually requiring us to spoil the mini projects for future students. Another important question, working offline. So many students don't have constant or cheap access to the internet. It can be very difficult for some students to access the internet reliably. So we have set up the course in a way to make as much offline work as possible as we can. The only part of the course that cannot be replicated offline is the grader. So you can, first of all, download videos from the video downloads tab on your Jupyter Hub. I've called that out several times. On your home page in the control panel, there's a video downloads tab where I will maintain a Google Drive of all the videos I've shared so far. So I'll be updating this today with the remainder of the office hours from last week, as well as the new lectures. You can also download the Jupyter notebooks and run them locally on your personal computer. So, excuse me. To download those from your notebook server view, you should see a little button over here that looks like a download button. It has that downward arrow pointing onto some kind of block. And if you roll over that, it says download as zip. If we just click that, we can see it downloaded our home directory into a zip file. If we open that up, we see it contains data course, and there's all the modules in the course with all of our notebooks. So you can easily download all the contents of your Jupyter Hub pod. Now you can run those notebooks, as I mentioned in this question, by downloading the Anaconda distribution of Python, which includes the Jupyter Notebook server. So if you visit anaconda.com/download, you can download the Anaconda distribution, which includes Python, Jupyter, and quite a few data science packages that are commonly used within the community. Now, the exact way that Jupyter is launched varies by operating system. If you're on a Mac or Windows, they both have a GUI graphical program for launching Jupyter. If you are on Linux or are just comfortable with the command line, it's also possible to launch Jupyter from the command line. I do that myself very often since I am on Linux. But in general, it should be easy to find tutorials on how to do this, either videos on YouTube or written tutorials that you can probably find just searching on Google for instance, introduction to Jupyter, Jupyter tutorial, things like that. And as I mentioned before, the only part that has to be completed online is submitting solutions to the grader. You can even work on your assignments offline, manipulate the data, try and craft a solution. But once it comes time to submit it, that must be done on Jupyter Hub because our grader lives online. Is it possible to replicate the Jupyter repositories? Hopefully I just answered this, but yes, if you go to your Jupyter directory on Jupyter Hub and click this button, download as zip, that will download this directory structure as a zip file, and it includes all of your notebooks inside of it. I realize I showed that on my screen, but you can't see, you can only see my browser. So let's see, is it possible for me to, for instance, navigate? Yeah, so if I do dzb downloads, so here's my downloads directory, for instance. In it is a home.zip file here. And if I were to, let's see, if I unzip that real quick. Okay, so I've unzipped that, and now there should be a home, let's see. Okay, I have a data course directory now, which is up here at the top. And this contains all the directories and files that were in my Jupyter directory. So you think you did that? Yeah, it should download to wherever your browser downloads things, and you should be able to unzip it wherever it ended up and inspect that. For the recorded videos, I don't see an option to increase playback speed. I've never checked that. Let's see. As far as I know, I don't know how. I think YouTube does that automatically. So I don't know if there's anything I can do to enable that. Yeah, it happens automatically. So if you look at the older ones, that option is available. It probably just takes time for YouTube to process the video and add that option. So when the videos are newly uploaded, like the ones that I just uploaded for this week's lecture, that option will probably not be there. But if you give it some time, you should have the option to increase the playback speed if you so desire. So I think it just takes time for that processing to happen and to add the option. I tried doing this on Mac. It somehow didn't work. Okay, so there's an alternative, which I can show you. So first of all, one thing to try before trying what I'm about to show you is you may be able to oh, that's not what I want. You may be able to try again in a different browser. It might be that your browser, for whatever reason, doesn't like this plugin we're using. So you may want to try in a different browser. Alternatively, what you can do is open up a terminal emulator. So you can zip-r. I'll try and make this a little bit bigger. Datacourse.zip datacourse. And if we do that, it makes a zip file of the data course directory. You can click the check mark next to that, and that'll bring up a download button, and you can just download that zip file, and hopefully that will work for you. So I'll edit this question and mention that. So if this button doesn't work for you, you may want to try again in a different browser. Alternatively, you can open up a terminal, new terminal in Jupyter, and enter the following command. This should make a datacourse.zip file appear in your directory. And you can click the checkbox next to it, which should make a download button appear above the directory view. So there's an alternative for you. Hopefully that works. Great question. Yeah, that's how we used to do it. And then we added this new button, and the button is very convenient, but it does not work in all situations. That is true. Okay, and then there was one more thing I wanted to advertise, which is we use this. It's not very important. Not everyone's going to be interested in this, but we do use a number of packages that, or we have like boilerplate code here and there that doesn't serve any data science purpose and isn't really related to the curriculum or content of the notebook per se, but is rather there as a tool for us to help us in either the way we create content or deliver content, or just in our teaching strategies. So in the top of many notebooks, you'll see this import expect exception. And expect exception is a tool that we use while we're developing our curriculum. And I explain it in this answer here, but it's not something you would ever use normally in, as part of a data science project. And it's really just a tool for us. So you don't really have to worry about it. Okay, so those are the answers that or questions that I thought were important to answer over the weekend. I'll just be opening up some of the new questions. There's quite a few new questions. Let's see, I'm just going to close Windows to keep my screen a little organized. So I saw there's a couple of questions on about videos. When will videos be uploaded to the Google Drive where we make videos available for download? There was one saying not got video downloads for second week. Indeed, just the videos haven't been uploaded yet. So as mentioned in previous videos, I will try to upload lectures early in the week. However, as I am creating or recording the lectures as we go, and I have many other responsibilities, the schedule may slightly shift from week to week. I ask for your patience, and we'll try to upload them early in the week each week. The first lectures for the second week are just uploaded, and I will add them to the video links and video downloads tabs or sections soon. So yeah, just please be patient with me. And you know, there's a lot of it's a lot of lecture to do, and this is not the only class I teach. So I'll do my best to have those lectures up early in the week. But sometimes due to other responsibilities, it may take me a couple days. Is there boilerplate code for the point class where we could gather some knowledge about how k-means clustering works? So this is a question about the VC mini project, which I have not introduced yet. If you look at the VC mini project, we do provide boilerplate code, in fact. So, you know, there's an outline here of the class structure. This class should probably additionally have some other methods like mul and add and sub. These are mentioned in other questions. So if you're working through the mini project, by the time you arrive at the algorithm question about k-means clustering, you should have a fully fleshed out point class, because the previous 4 questions require that you have a working point class. So we do give you a little bit of structure, and we give you a lot of guidance throughout these questions. And by question 5, you should have a point class that works. We additionally give you boilerplate code for the cluster that begins to outline how that should work, and give you boilerplate code for computing the result. So all of that is present, along with a detailed description of how k-means clustering works and a link to a reference. So all of that is already in the mini project. If you have a specific question, I would be happy to answer it, but those are the resources that we make available to you already. So this is a question about, they have this Lucas-Lamer prime function that they've defined. and it contains print statements but no return statement. And they're wondering why they print out a bunch of answers, a bunch of results, but their list ends up containing only none. Recall that print does not return a result. It only prints text to screen. Your function should return a result instead of printing it. We can only assign or manipulate objects that are returned from a function. Things that are printed are for display purposes only. This is described in further detail in one of the first week lectures. I actually don't remember exactly which one, but it's probably, yeah, it's one of these 1.1 videos. It's probably functions or variables, but it could be another one. That said, I do want to mention this is a very nicely asked question. It's tagged with all the relevant tags. It gives a code example explaining or showing like what they're trying to do. That makes it very easy to figure out, you know, they share their results as well. And it makes it very easy to figure out why this student is having an issue. So this student has some code for answering the Mersenne numbers question, where you're supposed to print out the Mersenne numbers associated with the prime numbers between 1 and 65. And they're getting an error when they submit their solution to the grader. And the grader tells them that their answer is too short, and that it should contain 17 items. And if we look at their answer, it looks like it maybe contains about 17 items. But if we look carefully, we see this is a list containing a list, meaning it contains one item. And in fact, essentially, they're getting a formatting error here from the grader. Grader errors like this one indicate that our answer is not correctly formatted. In this case, it tells us our answer is too short and that it should have a minimum of 17 items. You can study the error message and find this information. It looks like our answer has about 17 items in it. I didn't count exactly. But if we look carefully, we see that our answer is a list containing a list, i.e. a list containing one item. The grader error additionally tells us that our answer should be a array, i.e. a list, containing 17 items of type number. Therefore, our answer should not be a list containing a list, but rather a list of 17 numbers. The point in their code where they're encountering this problem is, let's see. They are appending a list. Let's look at your code. See how this happened. If you evaluate B, you will find that you get a list of 17 numbers, which is what we want. However, in your Mersenne list function, you append this list to the MERL list, which means we end up with a list inside of a list. You may want to review data structures for information about how the append method works. So I've mentioned this before. I will certainly mention it again in the future. These error messages from the grader contain information that tells us about the formatting of our solution. And usually if we're encountering one, it's because the format of our solution is incorrect. Additionally, this, and someone pointed out, there's a cell that highlights what the answer should look like. So I'll add that here. In addition to the formatting information given in the instructions or by grader errors like this, we try to illustrate how your solution should look by providing a dummy solution. This is described in the introductory video, which I will grab a link to. Let's say, here we go. The Mersenne equals 7 times 17 line is this dummy solution. If you evaluate 7 times 17, you'll find that you get a list of 17 sevens, meant to illustrate a list of 17 numbers. While these are not the correct values, it's your job to calculate those. It illustrates the correct format. So that was a really long answer. Long story short, the grader is a little bit, it's not totally obvious how to use the grader. We try and provide you with as much information as possible and give you multiple sets of instructions. But it takes a little bit of study to get used to the grader. So it's really, really, really important that you watch the introductory video and listen to and read the instructions, listen to the instructions on the grader and how that works in the introductory video, and also carefully read the instructions in the mini projects. How can we access Google Drive, WQU Google Drive of past videos? The video downloads tab will have all the videos for this course, and we'll upload them as we make them. So yeah, the video downloads tab is where you can find any video downloads for the course. I'm going to upvote this question just because I feel, but I'm also going to edit it. So IP mini project grader error for percent number question. I'll add some tags. IP mini project grader. So I don't think this question is asked in a great way. Part of that is because this student probably doesn't really understand what's going on, but they didn't put in a ton of work into describing. I'm actually going to take this comment and edit it back into the original question. Yeah, they didn't do a ton of work describing exactly what their interpretation of the situation was, but it sounds like they didn't really have one. But this answer is hopefully going to be very helpful to a lot of people. So I hope that this question does not disappear and that plenty of people see it. How long do the videos remain in the download option? So they'll remain on YouTube in perpetuity. However, we clear out the Google Drive periodically after classes end. Because we like to pace the release of the content, yeah, basically after the class ends, you shouldn't expect to maintain access to the videos in the Google Drive. So when the class ends, you should download all those videos as soon as possible because they will go away. They will remain on YouTube. So you may also want to copy out the links for the videos because they will stay on YouTube and you can always access them there. But the downloads go away. So you should download those as soon as possible once the course ends. So this student, let's see. It looks like for some reason they're submitting just the number 17 and not submitting a list of numbers. Please do not post solutions to the discussion board. Looks like they are constructing this list. It looks like they should be constructing the list correctly and then returning the list. So I'm not totally sure exactly what's going on here. Your code looks reasonable for producing a list containing this correct sequence. The grader is giving an error that tells us essentially that we're just submitting the number 17 to the grader. You should be submitting a list of 16 numbers to the grader. And if you evaluate 4 times 16, you'll find that the output is 16 fours. Your answer should be a list of 16 numbers, but the correct numbers in the sequence, not just a single number. I.e. not just 17. I'm also going to link to this question I just answered. You may want to check out this other question about grader errors like these, where I share more detail about how to interpret grader errors and dummy solutions like 4 times 16. Cool. I don't think this is the right solution, but they seem happy with it. So in my opinion, this is not the correct thing to put here. But if it works for you, then I'm happy you've solved the problem. I'm gonna, since VC is like well ahead of where I expect people to be at this point, I'm gonna skip over those questions for the moment and focus on questions related to the IP mini project because I want to make sure that people are firmly established with that before, people who are on IP or VC are already ahead essentially. Another question about videos. Your VC question. Also prioritizing logistics questions since only I can probably answer those. Open a chapter of Python from data course. It shows running while completely. How can I mark a course subject as completed? Great answer. Thank you very much for detailing how the course is structured for me. Okay, so how to reuse appended function. So quotes are not how we designate code. That's okay. Let's see. Okay, this looks like it's correctly formatted now. This is an answer, so I'm going to move it into the answers. Yep, so both of these are correct. You wouldn't get an invalid anything that says invalid syntax, but you would get a name error, which is what they indicate here, if you're trying to run a function before you define it. Yes. So name errors are very common for beginning students. If you want to run a function or call a function, you have to do it after the definition. Can't use list after using it in a function. This is not quite formatted correctly, so I'm going to have to edit this. It's all over. There we go. So they define a primes list in their print primes function. They can call that and get the correct primes. However, if they want to invoke the list, they can't do it. In your code, the scope of primes list is only within print primes start end, as a variable is not accessible outside the function, but since you return a list at the end of the function, the list is accessible by calling the function and assigning it to a new variable as below. Perfect. This idea of scope is discussed in the 1.1.x videos, particularly functions, and I think also in iteration and conclusion. Based on the Pi program flow notebook. You may want to review those videos. A great, great answer. I really appreciate all the help that you are giving each other. Okay, define LL prime as this. I want to test if it's true or false and place it into a list. Got a single output is true. How should I get a list of 1s and 0 values? Well, you should get more than just a single output, right? It's because they're initializing the list within the loop. You're getting a list with a single output because you are emptying a list on every iteration of the loop. So we've got this. This constructs a new empty list each iteration. Instead, we should initialize the list outside the loop. This will now give a list of 65 minus 3 equals 62 true and false values, which is also not what you want. Note, you can convert true to 1 and false to 0 by wrapping the result in int, i.e. int true is 1, and int false is 0. Just going to check that that's true real quick. Yes, it is. Great. Finally, we can let's see, what do we need here? Do we need a list of zeros and ones? Yeah, that's exactly what we need. Oh yeah, and it's in get primes. So I typed a falsehood here. We can combine these ones and zeros with the exponents by appending a tuple instead of just the result of LL prime. So people pointed out a number of these suggestions, but I think this reinitialization of the list in each iteration of the loop was really tripping them up, and no one identified that yet. So I didn't quite get to all the questions in the hour, but you know, that's what happens during the weekend. Is there's a lot of new questions, and then on Monday I might not get to all of them, but on Tuesday I'll usually catch up. So I'll carry on tomorrow with another office hour later on in the day, just as I did last week. And I'll try and get to some of these questions that I didn't answer yet. I'm going to sign off now. And I hope you all enjoy the rest of your day.